Hey guys, this is Sean Alexander with Alexander Tutoring. Happy almost summer. School is almost out. Oh my gosh, cannot wait. I'm sure we are all in need of a break for the summer, so congratulations to my graduates. I wish you all a great summer. Speaking of which, I want to do a very important topic today, systems of equations. And for our summer program and in general, we have certain milestones we like to see our students hit. And one of the big ones for me is, can the student solve a system of equations via substitution in which there are fractional coefficients? Coefficients is just the intimidating way to say the number in front of the x. So if they can solve a system of equations with substitutions when there's fractions involved, to me that proves that the student has really made it to a certain level, because there's a lot of different math topics included when you're doing a system of equations. You have to be good at fractions, you got to be good at your negative numbers, you got to be great at your algebra, what you do to one side. Check out all the other videos I did. You know how I feel about fractions. So it's what I consider a major milestone. And it's something we'll be looking for this summer in our summer program, Becoming a Math Student for Life. This is something we want our students to be able to do when they walk away from the program. And I think, as you'll see when we do the problem, maybe some of you watching haven't done math in a while. It's hard. High school math is hard. Okay, so let's do it. Step one in solving a system is we want to isolate a variable. So there's two equations, two unknowns, right? We got equation number one here and equation number two here, and we don't know what x and y are. Now it's important to understand that x is a number we don't know yet, right? And whatever number that is here, it's the same number here. So whatever the x value is in the first equation that we don't know yet, it's the same x value in the other equation. Same with the y. This y is the same as this y. Okay? So what we want to do, step one, is to isolate a variable. And we have four choices, right? There's two variables in the first equation, two variables in the second equation. We want to isolate a variable of our choice. It'll work no matter which one you choose. So usually we'll just want to choose the one that makes your life the easiest. I'm just going to start with equation one. I think that this y right here will be a good choice to isolate, because you can see that it's almost isolated. This is a mistake students make a lot. You think that y is all by itself. It's not. Why? Why? Because of the minus sign. So I'm actually going to flip this equation around. Doesn't matter which way we write it. Same thing. Okay. A lot of students, a mistake I see a lot, would just stop right here and say, we have isolated y, but you haven't, because there's a minus sign. A lot of students struggle to know what to do with the minus sign, and what you do is you multiply both sides of the equation by -1. Okay? And I'm careful to use parentheses here because I'm multiplying. This doesn't say I'm multiplying. This is -1 minus y. So it's important that I put this in parentheses too, to make sure that we state that it's -1 times -y. And then what we do to one side to do to the other, again, it's very important to use parentheses here. So I'm going to multiply the the right-hand side by -1 as well. Why are we doing that? Because a negative times a negative is a positive. See, you got to know your minus signs, something that a lot of students struggle with in order to get this right. So on the left-hand side, -1 times -y is just y. And you can see that that successfully isolated the y, got rid of that minus sign. Now here's why the parentheses are so important on the in general and on the right-hand side, is because this -1 it distributes to both terms here. So again, if you can do this, you must know how to distribute well. A lot of students wouldn't forget that step. Okay, so you can see that's just going to flip the sign around, because -5/7 times -1 is 5/7. And -1 times -11 over 7x is positive 11 over 7x. Okay, we've successfully done step one, which is to isolate a variable of our choice. Step two is to substitute that value, that variable, into the equation that you didn't use. So I use equation number one here. So that means we're going to substitute this in for y in the equation that I didn't just use, which is equation number two. So we're going to plug this in for y right there. Okay? Because remember, whatever y in the first equation is, whatever number that is, it's the same number in the other one. Again, whenever you substitute a value, it's very important that you use parentheses every time. There's another skill that you need to know that comes involved with this. So 5/7 plus, and I'm going to call this 11. I'm going to put the x on top. which is doable if you think of this as x over 1, right? And you know how to multiply fractions. You multiply across the top and multiply across the bottom. And the reason I'm going to do that is because it's going to make it easier in a second. Okay, equals. We've got to make sure and write down the right-hand side of the equation. Okay, we have successfully completed step 2, which is to substitute the variable that we solved for in step 1 into the other equation. Okay, now we have some simplification to do. We're going to want to distribute this too. So you got to be good at distributing. Okay, and we'll think of this as 2 over 1. Again, you have to be good at fractions. And we know multiplying is the easiest thing you can do with fractions. Please watch my fraction video if you haven't already. Most of you know how much I whine about fractions. Okay, so 2 times 5 is 10. 1 times 7 is 7. Plus 2 times 11x is 22x over 1 times 7 is 7 equals 7 plus 5x. Now, what we see here, we have a situation in which we have variables on both sides of the equation, meaning the x appears on the left-hand side of the equation and it appears on the right-hand side of the equation. So your algebra's got to be good here. You need to know what to do with that. And what you want to do is get all the terms with an x in it on one side of the equation and all the terms without an x in it on the other side of the equation. Okay, so it doesn't matter which way you go, so I'll just pick a random side. So I'll start with moving the 22 over 7x to the other side. So we're going to subtract 22 x over 7 from both sides. We draw a line right underneath. Equal sign always comes straight down. Okay, and now we evaluate what's left over on the left-hand side. You can see that these guys go to 0. That's the point. And we still have that 10 over 7. And on the right-hand side, I'm going to write this out all on a line. We have 7 plus 5x minus 22x over 7. Now, here's where you have to be good with fractions. And this is to prove a point. I always say that if a student is struggling in high school math, it's because of stuff from the 5th, 6th, 7th grade that they haven't mastered. And this is where you can see if you haven't mastered your fractions, which most students haven't, going all the way to seniors in high school, and you're trying to do a problem like this, how do you think your life is going to go? If you are worried about the fractions, you can see that this problem is way too overwhelming because it's much more involved than just the fraction, but they're in there, and you got to deal with them. And so a big part of our philosophy is to knock the fractions out early. So like over the summer program, Become an A-Math Student for Life, we're going to make sure students are totally confident in fractions, because you can see when we get to this Algebra 2 level material, if they're not confident in fractions, there's going to be a very bumpy road involved. But what we want to do is clear that path for them ahead of time. Okay, so what we need to do here to combine like terms, another thing that you have to be able to do with this, is we need a common denominator. So this 5x I'm going to put over 1. And then we want a 7 on the bottom, so I'm going to multiply this guy by 7 over 7. Okay, which is really 1. And so you're allowed to multiply by 1, doesn't change anything. But we can see that's going to give us a common denominator. Okay, so multiply across the top, multiply across the bottom. 7 times 5x is 35x over 7 times 1 is 7 minus. And you can see that we now have a common denominator over here. One other point I like to make, I always say that the sentence that I've said more than any other sentence in my entire life is only do one thing per line and copy everything down from the line above. A lot of students would not copy the 10 over 7 down from above. They would just sort of like work on what the chunk that they're working on at the time. Like they would just pull this part down because that's what we're working on. But that often leads to mistakes because it never gets put back together properly. So even though you're not working on it, we want to pull everything down from the line above. Okay, so we have our common denominator, 35x minus 22x is 13x, I think. And over 7. Okay, and so we succeeded in getting all the x terms to the right-hand side. Now we have to get all the non-x terms to the left-hand side. So I'm going to subtract the 7 from both sides. Draw a line underneath. Equal sign comes straight down. And guess what? Another fraction. You can really see how if you're not confident with the fractions, this is just completely untenable. Okay, so once again, we need a common denominator. So we're going to turn this non-fraction into a fraction by putting a 1 underneath. And then we're going to multiply by 7 over 7, which is really just 1, to get that common denominator. So we get 10 over 7 minus 7 times 7 is 49 over 7. Okay, 10 minus 49 is negative 39. Here you can see if you're not confident with your negative numbers, which a lot of students are not, you would run into trouble. And look at that, that's convenient. The 7s just cancel out if we multiply both sides by 7 to get negative 39 equals 13x. Finally, divide both sides by 13 to get x equals negative 3. That seems like a believable number. Next, we need to plug that in to one of our original equations. And at this step, you've always already solved for one of the variables, so there's definitely an easier choice. We've already gotten the y by itself, and that's always going to be the case. So all we got to do is plug in for x. So we have y equals 5 over 7 plus 11 over 7x, which is negative 3, which we'll call negative 3 over 1. Okay, and then we have a common denominator now. That's nice. And what's that? Negative 28 over. Okay, and we have an answer for x and y. Are we done? Hell no. You got to check your work. This is where a lot of students would be like, hey, I got numbers, I'm done, next problem. And that's something that's really important to us. It's so easy to just plug the numbers in to see if you got the right answer, because you have a way to guarantee the right answer. There's a way to know for sure, with 100% certainty, if you got the answer right. And on a test, that's really important. So a lot of students stop here, but we really encourage them to make sure you plug those numbers back in to make sure they still work. So let's go back to the original equation and plug those numbers in to make sure we get a true statement. So that's 2y equals 7 plus 5x. 2y equals 7 plus 5x. Okay, we're going to plug our solutions in. We got negative 4 for y, and we're saying, is this true? Does this equal 7 plus 5x, where x is negative 3? So we get negative 8 equals, does it equal? We're asking. Does that equal that? It does. Okay, we checked our work. We got the answer right. Okay, so thanks for watching. Again, the main point I always try and tell parents is, if a student is struggling in math, this is like an Algebra 2 level problem. It's usually because of things that they haven't mastered going back to the 6th, 7th, 8th grade, right? And you can see that something you learned in the 5th or 6th grade, fractions, negative numbers. If you didn't know, if you're not confident in those, as 7 out of 10 seniors in high school are not, how do you think this problem's going to go? It's hard, right? Like, this is involved. And, if you're not confident in your basic algebra, one instead what you do one beside the other, this problem's going to become way too overwhelming, and that's when students have meltdowns. So what we try and do at Alexander Tutoring, and what we're going to do this summer, is really make sure that our students are ultra, super duper confident in those fundamentals. Okay, that was a long one. Thanks for watching, guys, and have a great summer. Take care.